You're welcome once again to New Focused Approach to Mathematics Basic 8. This is revised edition. In this lesson, we are looking at performing probability experiments involving two independent events. This lesson can be found in page 294. Now, we are looking at two independent events. When we say events are independent, what does that mean? Now, two events, let's say event A, event B, are said to be independent events if the occurrence of A does not affect the occurrence of B, or the occurrence of B does not affect the occurrence of A. That's what we are trying to say here. Let's give you an example. For example, if I toss or throw a die once, we all know that the possible outcome will be 1, 2, 3, 4, 5, 6, right? Now, if I generate an event, remember in book 7 we said event is a subset of sample space. If I generate event called event A, which is odd numbers, and I generate that of even numbers. Now, you realize that these two events, the intersection is empty set. And when you are throwing a die which is fair, the occurrence of odd number does not affect the occurrence of even number. That is what we are trying to say. So there are two independent events. Any of them can occur independent of the other. So that is all we are going to look at. Let's take example and see. Now, before the example, we also have dependent events, which we'll look at it later, not in this year. They are events where the outcome of one affect the outcome of the other. So one can occur on condition that another has occurred, or the occurrence of one has something to do with the other. But we are not going to do that today. Let's take a question like a fair die or a fair six-sided die is rolled. We want to list all the sample space. Let me use S to represent sample space. And all the sample space will be either 1, 2, 3, 4, 5, 6. So these are the possible outcomes. Okay. Now the question says we should find the probability of rolling an even number. Okay, let's E be the even numbers that can be created from this set. We have 2, 4, and 6. These are the even numbers. What is the number of even numbers here? The number of even numbers, we have 3. Then again, you also know the number of sample space here also to be 6. Now, for us to find the probability of getting even number according to the question, will be the number of even numbers over number of sample space. This was a definition we gave for probability of an event. So number of even number we say is 3, sample space is 6. This is reduced to the lowest form as 1 over 2, and that becomes the answer. Then we want to find a number greater than 4. Okay, let me let A be a number greater than 4. Those numbers here, which of them is greater than 4? We have 5 and 6. So the number of events here is equals to 2. Probability of this event A will be equal to the number of the event over the number of sample space. Of course, the number of events is 2, sample space is 6. This can be reduced to 1 over 3, that is 1/3, and that answers the question. Then the last question says, what would be the probability of rolling a prime number? A prime number. So let's also define B as prime number, and prime number out of this set will be 2, 3, and 5. These are the numbers that are prime among the sample space. Note that 1 is not a prime number, okay? Because 1 has only one factor. So again, probability of we getting prime number is going to be the number of prime numbers are 3 in all over sample space, and that is going to give us 1 over 2 as well. So that becomes the answer for that. Let's take another example. Here, a box contains some identical marbles. 5 are red, 7 are black, 8 are white. We want to list all the sample space. Okay, so you have to define each of the parameters used. So 5 are red, let red R be the red. let B be the black, and black we have 7, and let W be the white, and they are 8. Now what is the number of sample space here? If you add all these together, you have 20. So number of sample space is 20. Right. Now we want to find the probability of selecting a black marble from the box. Probability of selecting black will be equal to the number of the black in the box over the number of sample space. So number of black we have 7, sample space is 20. And since we can't reduce this to the lowest form, we leave our answer as such. Then we are looking at number of probability of picking white balls. Probability of white also becomes number of white, which is 8, over number of sample space 20. And that can be calculated or reduced as 4 can divide 8 as 2, and 4 can divide 20 as 5. Then we go to the last question. Find the probability of picking a red marble. So picking red, which is equal to number of red, again, over number of sample space. And red we have 5, sample space we have 20. And so the answer becomes 1/4. And so that's how we handle. And you can see that all these events we've created are independent of the other. Let's take maybe last example. A fair coin is flipped once. Flipped once. A fair coin is flipped once. List the element of the sample space. Our sample space can be maybe letting head, H be head, and then T be tail. And this is only sample space that we have because it's only one fair coin that was tossed. List the element of the sample space. Probability of getting head. Probability of getting head. So probability of getting head means probability of, let's say, head will be equal to, how many heads do we have? 1. Total sample space 2, and that becomes the answer. Then find the probability of getting tail. Probability of getting tail will be probability of T also is 1 out of the sample space 2. Find the probability of getting neither head nor tail. Neither head nor tail. Once you throw the coin, it will either be head or tail. So if you say neither head nor tail, then our probability will be, the number of elements is going to be 0. So probability of, let me use the word neither here, neither H nor T. So we can say the number of sample space for this one is going to be 0/2, and the answer is 0. So there's no way you throw the coin and it will land and it will neither be head nor tail. Right. I'm sure this has really helped you. Thanks so much for watching this lesson.